Okay, so I hope you can hear my voice. It's a little noisy in the hallway, but I can't shut my door right now. I found this Khan Academy video that is covering exactly what you're working on, but he gets a little complicated. So I'm going to mute his voice, and I'm going to try to explain to you what it is he's doing. All right, so they're looking at these two triangles, and they're trying to find BC, line BC right here where I'm going with my arrow, okay? So actually the beginning does make sense, so I'm going to let you listen to his beginning. Okay, so here we go.
Has to figure out the length of BC. We have a bunch of triangles here and some lengths of sides and a couple of right angles. And so maybe we can establish similarity between some of the triangles. There's actually 3 different triangles that I can see here. This triangle, and this larger triangle. If we can establish some similarity here, maybe we can use ratios between sides somehow to figure out what BC is. So when you look at it, you have a right angle right over here. Yeah, so in triangle BDC, you have one right angle. In triangle ABC, you have another right angle. If we can show that they have another angle or another corresponding set of angles that are congruent to each other, then we can show that they're similar. And actually, both of those triangles, both BDC and ABC, both share this angle right over here. So if they share that angle, then they definitely share 2 angles. So they both share that angle right over there. Let me do that in a different color, just to make it different than those right angles. They both share that angle there. And so we know that 2 triangles that have at least 2 of their angles that have at least 2 congruent angles, they are going to be similar triangles. So we know that triangle, I'll write this, triangle ABC, we went from the unlabeled angle to the right yellow right angle to the orange angle. So let me write it this way. Went from.
Okay, what he's saying is that both the big triangle and the little triangle on the right, BDC, they both have angle C. So if they both have a right angle and angle C, then they're similar. 2 angles the same make similar triangles. So going with triangle ABC, that's the big one, they're naming the right angle in the middle, and they're naming that little angle C last. And then they're going to do with the little one, BDC, because they're starting again, right angle in the middle, right, that's D, and little c last. Okay, let's see if he writes that. So we have triangle ABC similar to triangle BDC. And remember that order matters. So we're gonna go with order matters. Okay, then he's gonna set up a proportion. All right, so remember that the hypotenuse here on the little triangle, the hypotenuse is BC. That's the one across from the right angle. But in the big triangle, AC is the hypotenuse because that's opposite the right angle. Okay, so here he has it, AC, that's the hypotenuse in the big triangle, right? And he's putting that to BC, which is the hypotenuse in the little triangle. So it's hypotenuse in big to hypotenuse in little. So big we're gonna have on top, little on bottom, big, little. Hypotenuse, hypotenuse. So and then we pick long leg, or short leg, it's gonna again be big, little. Okay, so BC, now BC for the big triangle is the littlest leg. BC is the littlest leg, and DC on the little triangle is the littlest leg. So again, big, little, big, little, big, little. Big on top, little on bottom, big on top, little on bottom. Okay? BC is the shortest one for the big triangle, and DC is the shortest one for the little triangle. Okay, and he color-coded it, right? So he's also telling you that BC comes in 2 places. BC for the little triangle is the hypotenuse, that's here, and BC for the big triangle, big on top, is the short leg, right? So now we need to say, we know what AC is. AC is 6 plus 2. AC is 8. So we can plug in 8 for AC. See how he did that? And then DC is 2, right? That's labeled for you. So he plugged in 2. So now he's saying cross product, 8 times 2 is 16, has to equal BC times BC, which is BC squared. So if 16 is BC squared, take the square root of both, and BC must be 4, because 4 times 4 is 16, right? Does that make sense? So I'm going to stop here, and then I'm going to make a second video to show you some other kinds of problems. And I hope that's a little bit helpful.